today is go over the syllabus in significant detail so that you know exactly how the grade scheme is set up, how and when to expect exams and that sort of thing. Talk a little bit about the structure of the course in general, and we will actually start on course material today. But most of what we do will be structural information about the course itself. And at any time you've got questions going through this, feel free to jump in with your questions. 233 up here is my office number. The classroom is 223, but my office is 233, which is back behind this wall in one of the little alcoves back there. The 539 phone number is my office number. Most of the time I'm here on campus. I'm actually in a class, so I'm not actually in my office all that much. If I'm there, I will answer the phone, but I don't check voicemail messages from home. I do check email almost constantly, even from home. So email is definitely the recommended way of getting in touch with me. If I'm not actually physically here and available to you, then email is the best route. All right. Again, is there anybody I missed with the syllabus or the information sheet? Then let's start by going through the syllabus. This is Chemistry 1110, General Chemistry 1. You'll notice from the entry-level standards and prerequisites that previous courses in chemistry are not a requirement. What is a requirement is being decent at math. We do a lot of algebra. We don't do anything beyond algebra, but you need to be good at algebra. People that are not very good at algebra, they hit a block real quick, all right? So if you know that algebra is a weakness for you, then make sure that you get help in doing calculations starting today, if possible, because we do a lot of, it's really Algebra 1 type stuff, but only a little bit of it would actually be considered Algebra 2 even. But the point is you've got to be good at it. Otherwise, that's too big of a hurdle. That holds you up on the math portion, and then you quickly get behind in all the rest as well. All right, so please brush up on your math skills if you know that to be a weakness. Under textbook information, we are using the second edition of the Burge Chemistry book. 1110 lab notebook. You will be having lab this week. All right, so make sure that when you go to your lab that you have the lab manual with you. You will need that. We'll also talk about the dress code for lab in a few minutes. We'll get to that in a few minutes. And then in bold print and italicized, still under textbook and other materials, it mentions calculators. Programmable calculators like TI-82s, 84s and stuff are not allowed. You need to have a scientific calculator, but you cannot have a programmable calculator. You can get a good scientific, non-programmable for $8 to $10. You need to have one of these. Well, it doesn't have to be one of this. You know what I mean. Any kind that is scientific but non-programmable is what you're allowed to use on exams. All right, so make sure that you have one by the time we get to the first exam and practice with it, because you need to know where all the functions are. Starting at the bottom of the first page and working its way onto the second is a list week by week of the topics that we'll be discussing and the corresponding section numbers from the text that go along with those topics. That gives you a general idea of what we're covering when. Let me go ahead and mention this now. There is a D2L course component for this. It's a merged one between us as a Monday-Wednesday class and the P07, which is Tuesday-Thursday class, 305 as well. So both of those are merged into the one content section. You should all have access to that now. Please make sure that you do and try to log into that at some point soon. And if you're not able to log into that, then let me know by Wednesday so we can get the problem taken care of. But you have a lot of resources on that side to help you through this course. One of those is the course calendar. And so this weekly listing on the syllabus is nice, but the calendar on the D2L side is much better because it tells you day by day what we're covering. It gives you tentative dates for all the exams. So you can go ahead and be planning around that if you need to make arrangements around exam dates or anything. So make note of the calendar that's on there for scheduling purposes. Also, under course content there, you've got a lot of documents that are laid out chronologically in the order that we'll be going through them, and for the most part chronologically. And that's practice material in helping you prepare for the exams. So the calendar on there is better, more specific, and your actual practice resources as far as what do I need to do to be ready for the exam, those practice materials and answer keys are on there as well. Any questions so far? All right. Second page, Roman numeral 2, evaluation, 1,000 points. Testing procedures, 600 points. More than half of your grade comes from your performance on exams. And that the way that these exams are set up is as we go along, you'll have 5 exams periodically. Usually it's like every 2 weeks, but occasionally maybe every 3. But you'll have these exams. Each of them is worth 100 points toward the total, except you're able to drop one of them. So just for example, just for pretend, let's say test 3 doesn't go very well. Maybe you oversleep or something. Then these other 4 are going to count, and each of those makes up 100 points of your grade. You're able to drop one of the 5. Lowest of the 5 is the drop. Unless you miss one, then that of course is a 0 and technically the lowest, and therefore that's the drop. Right? You're able to drop one of those, so of those exams, 4 of them are going to count, and that's 400 possible points of the total. Format of these varies depending upon the content. On D2L, you've got practice exams, which in semesters past were the real exam. And so you can look back at those and see, is test 1 going to be mostly mathematical or mostly conceptual or things of that sort. It gives you good ideas of what to expect with each of the tests as they come along, what they're going to be like. So you have those to help you prepare for the real ones. 4 of those are going to count. Format primarily will be calculations and explanation type things. And by explanation, I mean more than just a plain definition. It won't be define such and so, but explain how such and so process works. Something that may take you 3 or 4 sentences to give a good explanation for it. But like I said, the content of that will change a little bit depending upon the topics involved. You also, at the end, have a final exam, and that's worth 200. Final exam is comprehensive. It's multiple choice. It is not droppable. This course pretty much is cumulative. I mean, because things that you learn you learn for test 1, you still need to be able to do on tests 2 and 3 and 4 and 5, because it just builds. The material itself is cumulative in that sense, and so that's why the final exam is cumulative as well. 200 points there, so collectively that's the 600 points that comes from actual exam grades. Is there any question about that? Everything that you do in lab makes up another 250 points. That adds up to 850. There's another nebulous 150 points that, let's just say, I've not decided what that's going to be yet. All right. It won't be tests, Promise you that. It won't be exams. You got enough points in exams already. It'll be out of class in some form or fashion, that things that you would do to make up that 150 points. And I'll get that figured out by the beginning of next week, and then get that information to you. So collectively, that's your 1,000 points. 250 is lab-based, 600 is exam-based, and the other 150 unknown for the moment. Question? Yes?
Attendance or homeworks?
Attendance, you mean as far as grading? Or attendance is important, yes. You don't get points towards your grade based on attendance. Homework, you're not turning in anything to me. As far as like textbook homework or the things that are on D2L, those are purely for your own practice. You don't turn those in for grading. Now, there will be some things that I put on there on D2L periodically that may be on there as turn-in assignments, and those may be part of that 150 or they may be bonus. Okay, there will be things like that that pop up that you do turn in, but there is no regular systematic homework that you turn in. There's a lot of materials on D2L. You do as many or as few as you feel like you need to be ready for the exams. All right, the key is being ready for the exams. Question? Question about grading. 1,000 points is your possible total. We work on a 100-point scale, so 900 and up is an A, and so forth. The scale is here in the syllabus. This will be the front of the second page. Item D, grading scale. 900 to 1,000, that's an A. 875 to 899, that's B+, and so forth on down through there. It's basically a 100-point increment with a little bit at the top to allow for plus grades. Any question? All right. Under policies, there's several of these. You need to read through these, understand these. You will be held to these. The only one that I want to, I guess, mention here, the only two here that I want to mention here as collectively as a group is where it says cheating and plagiarism. Please bracket those two together. You will have some things that are done out of class, whether it's bonus or whether it's part of the 150. There will be some things that you do out of class. And unless I specifically tell you it's a group project, it's open book, you can work with other people, then assume it's not. All right? You do your own work. Cheating or plagiarism is turning into me as your work something that's not truly your own work. When you turn in something with your name on it, you're claiming that's your work and solely yours. And if that's not true, then that comes under cheating and plagiarism. Question? Group projects are different, but don't assume anything I give you is group. All right? It's not, unless I explicitly tell you that. Question? All right. The rest of the syllabus you may read through on your own. Make sure that you read through it by next class period and get with me about any questions or concerns that you've got. Any questions about the syllabus or the structure of the course? Yes?
Textbook. Is there an online dish report, an ebook?
There probably is. I don't have the information for that.
All right.
But yeah, I believe there is.
All right.
Other question? As far as preparation goes for exams, what I would recommend as your hierarchy of importance is you'll always have for each exam what's called a study pack. The first one I'll give to you here in a moment. The rest of them are on D2L, and you just print from there and bring them with you. But the first thing you should do is go through the study pack and all your notes from lecture, make sure you understand those. Second, go into these other D2L materials and work everything that's on there. And then third, if you still don't understand things, that's when you get into the textbook homework and get extra practice problems that way on the areas that you know to be your weaknesses. All right? But the study pack I made, the stuff on D2L I made, those are probably going to be the most similar to the tests that I make simply because I made them. All right? It'll have the same emphasis, it'll have the same phrasing, it'll have the same importance, I guess you could say. So your best resources are what's on D2L. Other question? The information sheets, if you'll please pass those to the aisle, I'll come around and collect those. Anybody I missed? All right. You do have lab this week on D2L on this site as well as the Chem1110 all lab site. It gives you information on dress code. And I want you to refer to that before you go to lab this week, but just briefly telling you now, the three things that are required for you to even be in that room is you've got to have leg coverage to the ankle. You've got to have shoes, closed-toe shoes, closed-toe heel that will completely cover and protect your foot. And you've got to have eye protection. And on the doors, facing in and out both actually, you've got a little flyer there that tells you what is and what is not acceptable as far as eye protection. All right? Eye protection, leg protection, foot protection is what's required. All right? If your pants stop here and your ankle starts there and there's skin visible, then you are not adequately covered. All right? So make sure you're dressed appropriately when you go to lab, or you will not be able to go in, you will not be able to participate, and then that's going to be points lost. All right? So I know that's brief, but check online. It gives you very specific instructions about what's appropriate for lab. You do? Okay. So this is the study pack for exam 1. This is the one and only time that I will give out study packs to you. All the rest of them are on D2L. And so when we get past exam 1 and we start on material for exam 2, you need to print the next one, bring it with you. These are skeletonized versions of the notes of what we're going to be going up through here. They are deliberately incomplete. So for example, the whole first page is terms that you need to know the definitions of, but I didn't give you the definitions. That's because some of them we'll talk about as we go through class. Others you'll need to look up on your own. But you are responsible for everything in this study pack unless I stand up here and explicitly throw it out. All right. So of these definitions, maybe we do half of them today. Maybe the next day or two we come back and hit a couple more. If there's some that we don't talk about, that's things you look up on your own. All right. We don't have time to cover every little detail here in the lecture class. So you are responsible for everything in here, and if we don't cover it, you fill it in on your own. All right. This lists all the concepts. Most of the concepts have practice problems associated with them. Most of the practice problems have answers given. And most of those answers are correct, but I wouldn't promise they all are, because mistakes get made sometimes. Right? And I'm not the most efficient editor that ever lived. So sometimes mistakes live from one semester to another. But if I catch one, I'll point it out. If you catch one, please point it out, and I'll try to get those corrected for the future. But theoretically, all is good with this. All right. Any questions about anything before we actually start on material and start working our way through these notes? Starting off with this page of definitions, some of these may be familiar to you. Please notice that for the most part, they're listed here in pairs. Heat is listed alongside temperature, compound with mixture, accuracy with precision. That is intentional because within each pair, sometimes they're exact opposites, and so studying the definitions together will help you remember them both. And in other cases, there may only be a very subtle difference between them. But either way, if you take them in pairs, you're taking them in context, and that'll help you clarify the differences between the two. Right? So study them in that manner. Very early definitions here. First of all, as far as what chemistry is in general, just what chemistry does, is we study what things are made of, and we study changes. If you've got a rock or a piece of wood or something else, you want to break it down and see what it's made of atomically. The periodic table up there on the wall gives you the list of elements. And it's the combinations of those elements in whatever proportions that makes one substance different from another. We look at what things are made of. But we also look at changes, or in other words, reactions, in terms of how to convert one substance into another. So not just composition, but how to change the composition of something to get properties that you want something to have. Matter and energy. What's a good general science definition for matter? Yeah, good. Anything that has mass and takes up space. Anything that has any actual physical substance or presence about it. That's stuff. Anything that has mass or occupies space. There's this law called law of conservation of matter, which basically says there's only a certain amount of matter that exists. You can't make more. You can't destroy the matter that already exists. All you can do is change it from one form to another. So for example, if you've got a beaker full of water and you turn it up to boil and it goes away, that doesn't mean it doesn't exist. That means it turned into steam and it went somewhere else, correct? Or for example, if you take iron with water and it converts into rust, the iron didn't cease to exist, it became part of that rust. What we do in chemistry is we change one form of matter to another. You don't create matter, you don't destroy matter. In a sense, you're shuffling the deck. All chemistry does is shuffle the deck. You change the way that the elements are arranged, you get new materials with new properties, but fundamentally, all you're doing is reshaping the matter that's already there. You can't make more, you can't destroy what there is. There's a certain amount of matter that exists, and that's constant, period. Energy. What's a good definition for energy? That one's a little harder, because energy is not a substance. It's more of an ability. Energy is defined as an ability to move or do work. The ability to move or do work. And we have the law of conservation of energy, saying there's only a certain amount of energy that exists, and that amount is a constant. You cannot create energy. You cannot destroy energy. You can change one form of energy to another. For example, like a flashlight, you take electrical energy from the battery and turn it into visible light, correct? That's converting one form of energy to another. Question about either of those? All right. Kinetic energy and potential energy. What's a good definition for kinetic energy? Energy.
Anything in motion?
Yeah, energy associated with motion. What's potential energy?
Energy that has the potential to be in motion.
The potential to be in motion. So basically, in the classical sense, it would be the position of something. So going just strictly with classical definitions of kinetic and potential, an example would be like this marker. If I'm holding this marker out a certain distance above the floor, then it doesn't have any kinetic energy because it's not moving. But it does have potential energy because potentially I could let go, correct? Which means it would start to drop. So the position it has, that gives it potential, if I let go, that would be converted into kinetic, correct? All right. All right, question on either of those? Before I change the mic. Because neither one of those is good enough for chemistry. All right. When we're talking about kinetic energy in the chemical sense, let's say that those are the atoms that make up this marker. This marker's not a single object if you think about it on the molecular level. There's zillions and zillions of little atoms there, crammed shoulder to shoulder, locked rigidly in position, because this is a solid. They're locked rigidly in position. So they're attached, 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 attached. And within that rigid structure, nobody's going anywhere. They're all stuck rigidly in their position. But what you do have, for every single one of them, I'm just going to key in on this one. It does have motion proportionate to its temperature, because every little atom in there vibrates. They're sitting there, locked in position, attached to their neighbors, but they're vibrating back and forth in position in that structure. And that's based upon their temperature. If you heat it up, they wobble a little faster, and if you cool it down, they wobble a little slower, because cooling it down is removing kinetic energy. So, for our purposes, we don't care if the marker's moving or not. What we care about is temperature, because temperature is your measure of molecular motion. So whether this marker is sitting on the counter or flying across the room is completely irrelevant. The molecule's motion is based upon their temperature. Now, just for pretend, if this is a solid and we heat it up, they vibrate faster. And you heat it up more and more and more, they start to shake faster and faster and faster. Eventually, you would get to the point where you've put in so much heat that they vibrate loose from each other and start to flow. What's that called?
Melting.
Melting, because that would be converting your solid to a liquid. But if you kept on going even more, and yeah, you can let go completely, and that would be evaporation. Those physical forms is a result of that vibration. If you cool things down, they move slower and slower. And theoretically, you could get to the point of what's called absolute zero. That being the point where if you cool it down, they vibrate less. You cool it down more, they vibrate less. Eventually, you could get to the point where you suck out the very last bit of kinetic energy it had, and then they quit moving altogether. Zero kinetic energy. No molecular motion. Absolute zero as a temperature is defined based on no molecular motion. Now, as far as numerically, what temperature is that? We'll talk about that when we do temperature scales. But for now, just trust me.